Yes, artificial intelligence can help solve mathematical problems. In fact, artificial intelligence is already being used very successfully to solve mathematical problems. Artificial intelligence uses a number of techniques that can be used to solve mathematical problems. For example, artificial intelligence can use natural language processing techniques used to understand and analyze problems. In addition, artificial intelligence can use machine learning technology that performs mathematical calculations quickly and accurately. Also, artificial intelligence is used for mathematical modeling. This can be used in a variety of fields, such as simplifying complex mathematical problems or analyzing large-scale data to derive useful information. Therefore, artificial intelligence can be a very useful tool for solving mathematical problems. However, artificial intelligence is not limited to solving mathematical problems, but can also be used to solve various problems in various fields. What are the top 10 math problems in the world? The top 10 math problems in the world are as follows. Poincaré Conjecture. Riemann Hypothesis, Riemann Hypothesis. Polar Problem, PVSNP Problem. Fundamental Theorem of Arithmetic. Fermat's Last Theorem. Four-color Theorem. Quadratic Reciprocity. Brocca-Libbert Problem, Brachistochrone Problem. Cantor's Problem. Hilbert's 23 Problems. These math problems are very difficult, so many mathematicians are working hard every year. Some problems have already been solved, but mathematicians continue to study and make efforts because there are still problems that have not been solved. Which of these math challenges has been proven? Among the top 10 math problems in the world, the following are proven. Fundamental Theorem of Arithmetic. Proven in the way Euclid devised. Fermat's Last Theorem. Proven by Andrew Wiles. Four-color Theorem. Proven by Kenneth Abson and Walter Hepton. The rest are unproven problems, and many mathematicians are still working on them. No, isn't Poincaré's guess solved? Yes, that's right. There was a mistake in my previous answer. Poincaré conjecture was demonstrated in 2002 and 2003 by Fermat and his colleagues who worked in graph theory. Therefore, the Riemann hypothesis remains one of the top 10 mathematical challenges in the world that has not been proven to date. I'm sorry. Isn't that a Russian mathematician? Yes, that's right. I checked again, and the Poincaré conjecture was a problem proposed by the French mathematician Henri Poincaré in 1904. However, the proof of Poincaré's speculation was published by Russia's Grigory Perelman in 2002. Once again, I apologize for the inaccuracies in my previous response. Then tell me by whom the difficulties that have been solved are demonstrated. Among the world's top 10 math challenges, the challenges that have been proven are as follows. Fundamental Theorem of Arithmetic. Proven in the way Euclid devised. Fermat's Last Theorem. Proven by Andrew Wiles. Four-color Theorem. Proven by Kenneth Abson and Walter Hepton. Thus, the basic theorem of positive integer theory was presented by the ancient Greek mathematician Euclid, the last theorem of Fermat was proved by Andrew Wiles in 1994, and the four-color theorem was proved by Kenneth Abson and Walter Hepton in 1976. What is the positive integer theory? BNP. I don't think this has been proven yet. The theory of positive integers is the study of integers, a branch of mathematics that deals with positive integers and their properties. Positive integer theory deals with prime numbers, factorization of prime numbers, factorization of polynomials, etc., and important issues in this field include the distribution of prime numbers, the determination of synthetic properties of prime numbers, and the division of sets. On the other hand, P and NP are one of the important problems in computer science. P is a set of problems that can be solved in polynomial time, and NP is a set of problems that can be solved in polynomial time. Some of the P and NP problems have not yet been proven. For example, whether the P and NP problems are solved or not is the same problem or different is still an open problem. What is the Riemann hypothesis? The Riemann hypothesis is a hypothesis that describes various rules related to prime numbers discovered over the years since the ancient Greek mathematician Euclides. It was presented by German mathematician Bernhard Riemann in 1859, and is one of the most famous mathematical problems that has not been proven to this day. The Riemann hypothesis is closely related to complex hermeneutics and prime number theory, and deals with the analytical properties of Riemann's zeta function. This hypothesis provides rules for the distribution of all natural numbers, and can explain the regularity of the distribution of prime numbers in particular, which is mathematically beautiful and has important properties. If the Riemann hypothesis is proved, it is expected that many problems related to minority theory can be solved and that it can provide insight into many mathematical problems that are currently intractable. What is the equation of the parabola? A parabola is a graph of a quadratic function and can be represented by the following equation. Y equals x squared plus bx plus c, where a, b, and c are constants, and a is not zero. In this equation, A determines the direction in which the parabola is opened and the shape of the parabola, and the equation of the parabola with h, k, as the vertex can be expressed as follows. Y equals A, x, h, squared plus k, where h, k, is the vertex of the parabola, and A is the constant that determines the shape of the parabola. Is that a math problem? Is it proven? No, the parabolic equation is one of the mathematical concepts, and it's not a math problem. Also, the parabolic equation has been discovered more than 2,000 years ago and is one of the most well-known concepts in mathematics. So this equation has already been proven, and it's covered in a lot of math textbooks. What's Brachistochrone problem? Brachistochrone problem, Brocard-Ramanujan problem, is the problem of finding a positive integer solution of the following equation. N equals m squared plus 1, where n represents the factor of n, i.e. multiplying all natural numbers from 1 to n, m is a positive integer. The problem was studied by French mathematician Ferdinand Brocard and Indian mathematician Srinivasa Ramanujan in the 19th and early 20th centuries. However, finding a general solution to this problem has not been solved yet. However, the solution to this problem is known for certain values of n. For example, m values are known for n equals 4, 5, 7, 8, 10, 14, 18, 20, 24, 30, 38, 44, 54, 88, 96, 114, 118, 148, 244, 248, 1456. However, a general solution to this problem has not yet been found. Therefore, this issue remains an open issue. What's the problem with Cantor? Cantor's problem raises the following questions in collective theory. Can all real numbers in the 0, 1 interval be divided into two sets A and B containing 0 and 1/2? Where 0, 1 means a closed interval containing 0 and 1. This problem was raised by Cantor in 1874, which is often used as a problem to clearly understand the basic concepts of collective theory. Cantor's problems are solved in the following ways. First, there are infinite real numbers in the interval 0, 1, so you can divide A and B into sets with infinite elements. And for any real number x that exists in 0, 1, if x is a specific value like 0 or 1/2, you can assign x to either set of A or B, but if x is a real number other than 0 or 1/2, you can assign it so that it doesn't belong to either set of A or B. In other words, it is possible to divide all real numbers in the 0, 1 interval into A and B. This is one of the most basic examples of understanding Cantor's collective ideas.